You are about to be fixed. Physics Fixed. Better than real. Where each brief episode brings insight you've never had before by smashing through conventional barriers. It's Occam's razor in the hands of Jack the Ripper. In the last 3 episodes, Phyxed boldly identified quantum spin 1/2 as primarily chronaxial, projecting a symmetric field of spin components in all spatial directions. We're going another round, this time looking at spin from Emmy's perspective. Spin 1/2 is real angular momentum, a conserved quantity, and thanks to the brilliance of Noether, every conservation law is now associated with a symmetry. Symmetry is transformational invariance. A property exhibits a type of symmetry when it's unaltered or conserved despite facing that type of change. For example, conservation of mass energy corresponds to the symmetry called time invariance. That is, translation through time does nothing to alter the total mass energy of an isolated system. This is an exact law because no exceptions are ever anticipated. By comparison, it divides into 2 approximate laws, conservation of mass and conservation of energy, which each hold, barring interchanges between them. But such interchanges are possible as by nuclear fusion. Another exact law is conservation of momentum, which is invariant under translation in any spatial direction. Thus, in terms of translation, all 4 dimensions are accounted for. But when it comes to rotation, conventional physics has a conspicuous blind spot. That's about to be fixed. Exact conservation laws list only the x, y, and z dimensions for symmetry associated with angular momentum. Yet we've been given the following. Quantum spin has nothing to do with motion in space. Spin is an intrinsic property of a particle unrelated to any sort of motion in space. Clearly, at least one non-spatial axis should have been listed to accommodate spin 1/2, and the only axis not yet accounted for is time. Otherwise, the table of exact symmetries is itself internally asymmetric. It is inconsistent to purport 4 dimensions of translation, but only 3 dimensions of rotation. And similar to conservation of mass energy, which divides to approximate laws for mass and energy, conservation of angular momentum, barring interchanges, divides into approximate laws distinguished by the dimensionality of their angular velocities, given the symbol small omega. Conservation of linear angular momentum is exemplified by vibration and simple harmonic motion. Since no angle is described, linear angular frequency is 0. Conservation of planar angular momentum includes classical spin and orbits. Planar angular frequency is 2 pi f radians per second. Conservation of solid angular momentum, which is chronaxial, entails fermion spin and, as we'll eventually see, orbitals. Solid angular frequency is 4 pi f steeradians per second. Classical planar spin isn't adequate to represent spin 1/2, but chronaxial solid angular spin is. Fundamental unidirectionality restricts time to the role of axis, and we've previously seen that, whether considering 4 pi steeradians or 4 pi radians, the Planck constant is insufficiently reduced by 2 pi classical radians. The solid angular phase relation between 2 spin components of a fermion is expressed as the probability that they'll have the same sign. Probability amplitude is the projection of 100% self-correlation on their bisector and exhibits a 4 pi or 720 degree rotational range. More to come when Phyxed addresses entanglement. Though ill-considered that science acknowledges 4 dimensions of translation but just 3 of rotation, allowing a temporal axis does not itself solve the mystery of quantum spin. To reveal quantum spin, we had to lift the veil of space. Invariant interval coordinates provide a simpler Euclidean geometry in which space curves to receive a chronaxial spin field in all directions. The resulting curved space radial time model embeds all fermions in that space with a temporal spin axis available to each. Bohr stated, "However far quantum phenomena transcend the scope of classical physical explanation, the account of all evidence must be expressed in classical terms." Quantum spin is classical spin about a non-classical axis. It is chronaxial spin. In 1986, Wheeler said, "Behind it all is surely an idea so simple, so beautiful, that when we grasp it, in a decade, a century, or a millennium, we will all say to each other, how could it have been otherwise? How could we have been so stupid for so long? We don't have to be stupid about quantum spin any longer. Expand your horizons. It's about time. Congratulations. You've been fixed. Next time, we're going for a field goal as Phyxed kicks off field theory. I'll see you there, if you dare. Ha ha. Find other symmetry links in the description below.